The motivation for this project comes from what you're seeing here, driving around a large, busy parking lot and not knowing where to park. So this is a Costco in the Bay Area of California, and I use this as a model for my project. In particular, I measured the parking spots as well as the lights, how tall they were, because the idea would be we would like to mount cameras on top and run object detection. So then I built a small replica of what I saw at Costco using my Raspberry Pi and the camera attached, appropriate to scale, and had fun building that. But then I knew I didn't want to do just one, so I ended up doing 3 different cameras.
All right, in terms of layout and setup, we have our replica version of a Costco parking lot on this tri-fold cardboard cutout here. And then we actually have 3 separate cameras running. The main being the center, the Raspberry Pi with the Pi camera. And actually connected to the Pi as well, we have an additional webcam. And then just for fun, I actually have my old MacBook Pro as the 3rd camera, each focusing on what I'm calling a column of a parking lot. And then all of this is going to end up sending data to the back end, which is this laptop over here, which is also serving as the front end, which I'll get into shortly here.
All right, so let's give this a demonstration here. So I'm going to get started by launching the backend server as a process which is happening on this computer here. Great, so now we've got that started. Now I'm going to start the devices and let those communicate with the backend. So we see here, I'm going to try and start the device that pertains to the right column of the parking lot. And this is going to happen on the Raspberry Pi. So this is actually using the webcam, if I've got it right. Make sure I've got the right. Yes, indeed. So I'll try and have these close together. And then as object detections come through, put requests go through to the back end. So a bunch of put requests for this right column come through. But let's also do a similar idea here for the center. So this time we're going to do the center, different camera ID, but also on the Raspberry Pi. So let's get that going. Different process. And we've got that going here. And then lastly, I'm going to use my MacBook. So this time we're going to run the script with the left column. You'll get started. Great. So let me pull these other windows up. It's a little bit clearer. So these are what the devices are seeing, which should be very similar, or which line up with the parking lot. But now, as a last step, we need to get the front end going. So put up a new terminal here and navigate to the proper spot. Great, and let's start the front end using Node. Okay, and bring it over. So I'm going to rearrange one more time. Okay, so down below we have what the devices are seeing, and up above is the front end, what the clients would see. Imperfect, certainly, but let's see if we can get it to work as we desire. So I'm going to step over here and you'll see my hand. I'll start in the center And I'm going to add an object, which normally would be a car, but for simplicity's sake, I'm going to use this stop sign here and put it in a parking spot. And wouldn't you know, it's detected as such. Let's add another. Let's see if the front end detects it. Great. All right, let's try a few more of some of these other devices. So I'm going to work on the left column now, which actually happens to work the slowest on my MacBook, interestingly, but looks good. And let me also try on the webcam that's connected to the Raspberry Pi. So the second camera connected to this Raspberry Pi, just because I was limited on resources. So beautiful. Let me add, it works a little bit less well farther away, but nonetheless, let's see how this does. Yeah, no, we lost that one. Let's move it a little closer and see what we get. Yeah, it's a bit better. And so you'll notice this right column is longer in that just the way this camera is positioned, it can actually see a few more spots further up than the other ones. So that's how the front end displays it. And you'll notice the way the code is working here is essentially any object that it detects, it looks for the midpoint of the bounding box, and then if that midpoint is within a parking spot, it marks the front end as being occupied. So for example, my hand, I'll do here on the right side, has its own, will have its own bounding box, and since it's within this particular, parking spot, it's considered to occupy it. And you've noticed I've also taken away the detection of the stop sign. Oh, but it comes back and forth. So I'm limited by the skill and really accuracy of the object detection, but generally it seems to work quite well for our purposes here. So I'll add my hand in the center here as well, just for fun. So you'll see an additional parking space be occupied, at least per the center, the midpoint. So that's really the main thing that I was happy to create. Just for fun, I'll add a few more stop signs and see what all we can detect here. And this is the last one I've got, so you'll see not every stop sign is considered to be or detected as itself, and some of it changes as time goes on. I believe with an edge TPU, we could improve this accuracy, but by and large, I'm happy to have built a prototype that demonstrates the possibility of this.
I also wanted to give another view beyond just screen sharing. So here is the final positions that we had on the front end and what the cameras are seeing, but let me take a walk over to what's actually happening in reality. So here are our stop signs and then the various cameras detecting those objects.